Well, we're back in session, and Mr. Administrator, this is the moment I've been waiting for. It came much sooner than I expected.
Well, you look good there.
I've always wanted to be a committee or subcommittee chair, and it's finally happened. Up until now, I've been only the chair of the congressional delegation from the eastern part of the San Gabriel Valley and the western eastern part of the San Fernando Valley and the western part of the San Gabriel Valley, and that's my only chairmanship of one. I would like to start out and ask you about an issue that's near and dear to my heart. We had a chance to talk it over a little bit yesterday, and I know you can't be very specific given the budget numbers haven't been fully delineated yet, but would like to ask you your agency's perspective on the Mars program. It was on a very strong trajectory. That trajectory was changed over the last couple of years, and we've had some problems with the Mars Science Lab, which are hopefully now being corrected. But I'd like to get your thoughts on the future of the Mars program and whether you see an opportunity to make up for some of the ground we may have lost funding-wise over the last couple of years.
Sure. Well, as you know, the Mars program has yielded some incredible results, and with the first time a human machine, not a human yet, but a human machine has touched water on another planet, with the Phoenix landing, and of course the incredible discoveries of our two rovers on the surface and the orbital assets that are there. And we now need to go beyond those, as you were talking about. Ed talked about it earlier, alluded to it, but there's really, if I could expand on it a little bit and then let Ed add to it, there's really three pieces. There's the National Academy study that's going to go off and look at the entire planetary arena, the Moon, Mars, all the other planets, the outer planets, what have you, to determine their priorities and their rankings so that we have an assessment of the importance of the various planetary bodies as well as the missions that would be going there. Second, we've kind of collectively realized as a world that we're getting to the point where Mars exploration, we're starting to ask the very difficult questions, and very difficult questions tend to cost a lot of money. So partnerships are being forged. The most recent one is with ESA for the 2016 mission that we're working. And third, we've asked Scott Hubbard, who led the recovery after Mars 98, to go off and look at the Mars program and help us to put together a program of record that we can go off and look at. So those three things will all help us to, do more as we have partners that can provide resources, provide a better understanding of what needs to be done so that we can advocate for more or less, if it comes out that way, for the Mars program, and have a solid direction to go in. I don't know, Ed, do you want to add to that?
Yeah, if I can expand a little bit on the European Space Agency connection, because I'm in the middle of that for the past few months. Because of the problems with Mars Science Laboratory and the impacts that has on the ability for us to do the kinds of missions we want to do in the out years, we were facing a situation where the kinds of missions we wanted to do, we weren't going to have enough money for. In the meantime, I met with David Southwood, who's my counterpart in Europe, just last summer, and he was having the same problems with his Mars program. He has a 2016 mission that's very aggressive. His scientists have added a lot of instruments to it. And he was facing a situation where he just didn't have the kind of money that would be needed to do his mission. So that's where the idea came up. Maybe it's time. We've now reached the point where the easy things have been done on Mars. The really cheap things have been done. When you look at U.S. plans, U.S. science community plans, Western European plans, they're remarkably similar. We all want the so-called Holy Grail. We all agree at some point we have to send a robot to Mars, pick up a piece of Mars and bring it back for analysis in the billions of dollars of laboratories we have here right on Earth. That's going to be a very expensive mission, and it's going to be very expensive to develop the technology to get to that point. And since missions are looking like they're going to cost $1 billion, whether they're European or American, we kind of said maybe it's time for us to stop competing with each other, start working together since we have the same goals. And that was kind of the genesis of where we are now. We're going to Plymouth, England in June for our annual bilateral meeting. And that's where we're going to start trying to lay out not just a plan where we might do the 2016 mission together, but what I would call an architecture of where we're going to go from 2016, 18, 20, and so on, leading up to a Mars sample return. I think we all have agreed between us, the scientists, that there's no way one country is going to be able to afford a Mars sample return mission. We have to do it internationally, and maybe it's the time to start recognizing that now and do the whole program that way in the future.
What kind of collaboration, if any, do we have or might we have with the Chinese space program?
Today, on the science side, we have some collaboration, and we're expanding that a little bit more. The fundamental tenets that we have for the Chinese program is transparency, as we do with all of our other partners, within the bounds that we're allowed to have, as we were talking earlier about ITAR. And we have that on the science programs. I believe at this stage, and I have to be corrected, we have some efforts going on in earth science that we're doing. I do know we have a Landsat station in China that they utilize, and we're looking to expand that. On the human spaceflight front, there haven't really been any dialogues there yet because we really haven't. It's a much more complicated situation because anything that involves human spaceflight and going to the space station isn't really a U.S.-only question. So in addition to the transparency, it's our other partner nations on the space station that would have to agree to participate. So we have to have the dialogues with our international partners on that. But that's about the extent of it right now. Some limited science missions and activities are progressing, and not much in the way of human spaceflight yet.
Does the Japanese Aerospace Exploration Agency have a potential role in the Mars program, or is that something being explored as well?
Yes, the Japanese have played a major role in many of our programs, especially X-ray astronomy, and they have their own small planetary program even now. We have a collaborative mission with them on an asteroid sample return mission. I forget the name of it, but it's on the way back to Earth now with Japan and JPL. When I mentioned our working closely with ESA, it's not to preclude other countries. It was just that I was looking for other space agencies that could afford billion-dollar class missions, and certainly ESA is the only one out there at this point in time. That does not preclude us working with other countries, especially Japan, for contributions like a science instrument on a rover or an orbiter, that kind of thing. So we would welcome all comers, and Japan is certainly one of the strongest space agencies, other than U.S. and Europe.
Can you comment a little bit on the loss of the OCO and what options NASA is exploring to be able to replace the data that we would have had that been a successful launch?
Certainly. Like everybody, we were very disappointed in the loss of OCO. It had great potential and still does, but so that's been confirmed. We've asked the science community to go off and look at the mission and see if the data that was going to come from OCO would still be relevant and still be high priority. The answer came back yes. That wasn't really a surprise, but we had to answer that question. So we're in the process now of looking at what's the best way to go off and recover that mission. We're looking at two options. One, which would be to fly essentially a copy of OCO, and the other would be to fly the OCO instrument with the Landsat instrument, TIR, on a common bus. That one is a little bit more complicated because you have to work out the relationships between the two instruments and make sure that, since they'll be in the same orbit, to make sure that orbit is compatible with the science for both. We're in the process of evaluating that. One of the reasons it's not exactly a copy is OCO was we didn't have any spares, so we have to go off and acquire additional equipment that or we have to acquire the same equipment, and some of it is obsolete, so we'll have to go off and restart that. But we're looking at the earliest is probably a 3 years before we could have a mission flying again, principally because of that.
How will the cost of OCO change in doing a duplicate if that's the route that you take? You mentioned that some of the parts aren't made anymore and they've got to be redone. Some of the instrumentation may need to be updated. On the other hand, a lot of the work has been done. Do the cost savings in doing, again, largely what we've done before, are they more than enough to offset the additional costs of the new instrumentation or re-engineering the parts that aren't made anymore?
Again, it depends on which mission, and that's one of the factors that we're off looking at. But the short answer is it'll end up costing about the same. Clearly, we don't have to do the design over again, but we have to do the build over again. The spacecraft, I'm not 100% sure. I think it was an off-the-shelf spacecraft, so that's going to be essentially the same price as it was before. And the launch vehicle cost has gone up a little bit. So if we were to do a copy, we wouldn't have to pay for the engineering all over again. But that's a small part of the cost that we had to recoup. So it would end up being about the same cost, a little less, but about the same cost. So that's one of the other motivations for looking at flying the two sensors that I mentioned, the OCO sensor and the TIR sensor together. There may be an economic advantage as well as a scientific advantage to doing that. We haven't determined whether that's true or not yet, and that's one of the things that we hope to find out by the end, late spring, early summer, to have that answered, and then be ready to present a plan.
Thank you. Mr. Wolf.
Thank you, Mr. Chairman. And a couple of questions, and the bells have just begun to ring again, too. I just spoken to somebody earlier. They said that with the end of the shuttle that you potentially could lose thousands of employees. What are your expectations with regard to employee additions, losses, retirements, ages, and with regard to NASA based on where we are now and where you think we're going to be going?
With the retirement of the shuttle, we do expect to lose several thousand employees.
2,000 or
Current number is close to 10,000.
10,000.
Yeah, correct me if I'm wrong.
That would include all of the contractors who support the shuttle program throughout. Civil servants were about the same. We do a workforce report that's given to Congress periodically. We'll do further updates to that. As soon as we get the budget, we have reported, and you can go ahead and you can see and read for yourself the numbers of where they are. And the report's about 6 months old.
And where would they likely go?
We're trying to capture as many the workforce we can in the new program, the Doug's Constellation program. So we've been giving them some training opportunities to go learn some skills that help support his program. Some folks, again, it's not uniform across our workforce. Some of the older employees are ready for retirement. The younger employees have employment opportunities in other areas. The mid-grade group has opportunities to potentially, they're probably more susceptible to having to move to another industry than the aerospace. But our goal is to try to capture them and give them jobs in the aerospace community. They've provided unbelievable service to us. They have great knowledge. We want to use them in the most effective ways we can and engage them in Doug's program. So even though there's a period when we're not flying, we're still doing testing for Doug's equipment. We're doing test flight at KSC. We're starting to build up launch pads. We're putting infrastructure in place. We're doing analysis and those types of things. We can do those with the same workforce. So there will be a period where they'll be employed maybe in a slightly different job, but they'll still be able to contribute to this space.
But you're projecting there are a loss of 10,000 that would leave the agency? Or?
We don't know the exact number leaving the agency, but that's the maximum number that's in our workforce report. It's a function of how many jobs we can create. We purchase services as NASA, and then we let our contractors go do the actual employment and hiring. So the estimates we had, the worst case was the number on the order of 10,000. And that's, again, agency-wide and countrywide. And we'll see where they are. The lower ranges were on the order of,
Would they ever go work for Russia?
Don't don't think so. And that's Bill is indicating the difficulty that we have. We can tell you what you lose if you no longer do an activity, but we don't actually know what the contractors are going to hire back. So that makes it difficult to determine the lowest number, and that's what the higher number is based on, just what would be lost.
In the interest of a combination of a couple of questions, a recent article in Science quoted some unnamed scientist who blamed NASA centers, contractors, and members of Congress for exploiting a system of low initial estimates to get a project started, followed by pressure to fund any ensuing cost growth in order to protect the project and the jobs associated with it. What is your reaction to that critique?
Well, I think it's, let's say, exaggerated, unfair. Clearly, and I had mentioned earlier that we are working harder today to develop better estimates that we can provide to you, that we can commit to ourselves, so that we can do them more completely. And what are we doing to do that? We're working with the National Academy to help them develop better cost estimates. They're contracting with people that do cost estimates, so that they can develop better cost estimates. We've established rules for how we're going to do our cost estimating and assessing of our programs and projects from day one, and monitoring those monthly and quarterly and at periodic reviews, so that we can clearly understand what the costs are, and when there are threats to cost growth, be they underestimates, optimism in the estimate, or problems that come up. Either they're not getting the funding that they needed, they have launch vehicle issues, they have things outside of their control that they're going to need to go off and deal with. The earlier we can address those, the earlier we can make corrective actions that will limit or eliminate any additional cost growth. So we're looking at it from the very beginning, at those initial estimates, working with our colleagues in the Academy to develop better estimates, common estimates, all the way up until we actually deliver the spacecraft on orbit or on a planetary surface, so that we're looking at each step to make sure that we understand what the impacts are and how we can mitigate those.
One of the questions was, and you don't have to cover it, it's going to set up another question, but one of the major reasons why NASA does not seem to have enough funding to carry out its mission is the recurring problem of cost and schedule growth in your major projects. A recent GAO report found that 10 or 13 large projects they reviewed experienced cost or schedule growth that exceeded reporting thresholds. I guess the general question, because we're out of time and I assume we're coming back here, but what has happened to NASA? What do you think? I mean, this is not a fair question, and I'm not trying to put you on the spot. You don't have an administrator, and I think it's until you get an administrator, a lot of these can't be directly. You may not want to answer, but what has happened to NASA? What is it that the bloom is off with regard to, in the old days when there was a space shot, everyone knew it was Glenn, it was Shepard, we stopped, we watched it on television. I bet if maybe this audience would be exceptions, but we don't know the names of the last astronauts that went up. And it seems you've had leadership that's been somewhat political at times, and then you've had other leadership. And may not be a fair question, and if you don't want to answer, it's fine. But I guess I'm asking myself, what has happened to NASA? It's a great agency. You've done a lot of amazing things. America ought to be number one in space. We ought to be, just out there. It's kind of the American explorer concept, ideas, excitement, having young people excited about it, involved in it. And yet it seems that there's something missing, that something's been lost. No offense to anybody here. Obviously, I'm not attributing anything. If you want to take a shot at the end, what has happened to NASA?
I'll be glad to take a shot. Don't know how well I'll do, but I'll take a shot at it from a couple of different directions.
And I guess the question is that, do you agree something has happened to NASA?
I think our mission has matured, but I think that the NASA you see today is as vibrant and as capable as the NASA that you talk about from the 1960s. We have some incredible people. We're doing some absolutely incredible things that I believe from my, going around and talking to people, not that this is representative, but most recently to a group of seventh graders that were absolutely thrilled about what we were doing at NASA, and more than thrilled, they were as engaged and knowledgeable about the program as a geek like I was in the 1960s and 1970s when I was the same age as they were. So I think the excitement is still there. I think the difference is that the agency has matured, as many do, and as we said earlier, the problems have become more difficult. To think that we have built a space station. Back when I was a kid in the 1960s, there was 2001: A Space Odyssey. Space stations were science fiction. And we built this one over, was it 50 flights or thereabouts, with multiple other nations. It's an incredible accomplishment. We've landed spacecraft on Mars, discovered water. I think that, we've looked back at the Earth and we've made, the Earth a better place. Aviation, we continue to make, great discoveries in aviation that help our civil aviation as well as our national airspace system. So I think the difference that you're reflecting is a more mature agency that's addressing much more difficult problems.
The last question, and maybe, would it make sense to use the same language for the NASA administrator that you have for the FBI, a set 10-year term, non-political, nonpartisan, and so there is a continuity? I mean, you had Griffin and you had the other guy, and would something like that, has that ever been considered, or would that make sense to have a NASA administrator, non-political, 10-year term, only removed for a cause of action?
All I can say is it's never been discussed with me, and it certainly makes sense.
Okay, thank you, Mr. Chairman. I don't know what the time is, so.
I think we're probably out of time.
Are we coming back?
We have only about 3 or 4 minutes. We are coming back after the votes. Okay. Okay, we'll recess until after votes. Thank you.
Okay.